let us see another phenomenon of light which is exhibited in nature, that is reflection of light. And here also we explain this concept of reflection with the help of wave nature. So you can see how reflection undergo using wave nature. So while explaining the wave nature, we will draw the wavefronts. So in the first figure, you can see particle as well as the wavefronts which are striking one surface. After striking, they will change their direction. See, as well as you can see the wavefront. See, if the first end of the wavefront as it touches this reflecting surface, it will be readily reflected back. See, you can see the reflections of the wavefront. Let us see again. See, this is a reflected wavefront. So this indicates as a reflected wavefront, and this is the incident wavefront. So in this way, we can explain reflection of waves using concept of wave. So in the second figure also you can see these are the incident wavefronts. So it is hitting. From that point, we have to do a geometrical construction according to the Huygens principle. See, and we are drawing an envelope which is in the red color. That is nothing but the tangent to all the spheres that we are drawn to that point. So that gives the new position of original wavefront. So this is animation used to explain the reflection of light using concept of wave.
You already saw the reflection of plane waves using that animation. I hope you understood how reflection can be shown with the help of the plane wave. So here the cases we have to say that light exhibit a reflection phenomenon like a reflection using the wave. We have to Huygens should be able to prove that the reflection of light using his wave. So let us see how he has proved that reflection using his wave nature of that light. So see here, see this is the incident wavefront, waves which are incident. See this is the line drawn according to the particle nature, with the help of particle nature, and this is the incident, normal from the point of incidence. So this is the angle of incidence. So that ray will be reflected like this, making an angle of reflection R. So this is the incident wavefront. So after striking this surface, it will go this way. Okay? It will go like this. So I hope you saw the animation. And if the end reaches this point, sorry, I have to draw like that. This is the point. So R. So this is the reflected ray, and which is the wavefront. So that's why it is a reflected wavefront. So that will also make an angle of R. So that. So let us name the positions A, position A, B, and C, and okay. Let us we have to mention the positions A, B, C, and D. So this is an incident wavefront, this is reflected wavefront. So what we have to prove? We should show that using wave nature it is able to say that light undergoes reflection. So according to the law of reflection, it is known that angle of incidence is equal to the angle of reflection. So our ultimate intention is we have to prove angle of incidence is equal to the angle of reflection. That is what we have to prove. So to do that, from figure, in triangles, let us take the two triangle. This is the one triangle ACD, and triangle AB. Okay, we have taken the two triangles. Let us take the sine of the angles. Sine I is equal to this adjacent side AC. This is the opposite side. This is the hypotenuse. That's why sine I is equal to DC by AD. DC by AD. Okay, this is one equation. Similarly, sine R equal to sine R. This is R. Okay, and BD, which is a adjacent side. BAD is the opposite side, and AD, which is the hypotenuse. That's why sine R is equal to AD by AD. AD by AD. So which is equal to DC. DC means what? The wave which are the point C will reach point B. Okay? After consuming a time, it will take some time to reach from C to B. At what velocity? Let us say V. Because all this reflection undergo in a one medium itself. In the air medium itself or any other one medium. It doesn't require any two medium. So in this medium, let us say it travelled with the velocity V. So this is the distance from C to B. So at the same time, whatever the wave reaches the point A will also travel a distance to B. Okay? They will travel from A to B with the same velocity, that is V, in the time of 2. So that is a V. So distance from A to B is V. And here we have drawn a circle, part of the circle, which is according to the Huygens mathematical, geometrical construction. I mean, according to his. So we have drawn some circles having the radius of VT, so that it was able to find out the position of this reflected. Okay, let us write the values. So here CD or DC means VT divided by AD. Here AB means it is VT divided by AD. AD means AD itself. Equation number 1 and 2. So equation number 1 divided by 2. Now divide first equation by second equation, so that what we get is the sine A by sine R equal to VT by AD into AD by. So what happens? You will get 1, they cancel each other, so you get 1. 1 is also here. That's why what you can write is sine I is equal to, take sine R over there, 1 into sine R, which is equal to R. So sine I is equal to sine R for small angles. For small angles, I is equal to R. Hence, what we have proved is angle of incidence is equal to the angle of reflection. So which holds good the law of reflection. Which holds good the law of reflection. That's right. For Huygens is able to prove that I is equal to R using this same. So this is about the reflection of plane waves using the uses the plane surface.
Let us also see wave propagation in different mediums. Let us see how does a wavefront undergo refraction when it passes through a prism. Also, let us see what happens when a wavefront incident on a concave mirror, and let us also see what happens if a wavefront is passed through a double convex lens. So in this way we should know how can we explain the concept of wave for the different mediums. So let us see the first one. So here this is a incident wavefront, and this incident wavefront has to cross this prism, and when it passes through this prism it undergoes the refraction. So the lower part of this wavefront has to travel larger distance, because since there is a more thickness at this region, and the upper region of this wavefront has to travel very less distance through this prism. That's why the wavefront coming out of this prism will be tilted, somewhat tilted. You can see this, and also you can see here in this figure also, here AB is the incident wavefront, this is the incident wavefront, and CD is a refracted wavefront. So it has to enter this prism at the one end, it has to come out of that prism at the other end, but it is in a tilted state. So this happens because the wavefront at A has to travel more distance through this prism, so its velocity decreases, because the velocity of light in a denser medium is less than the velocity of a light in the rarer medium. That's why whatever the wavefront which passes for a longer distance through the another medium, it will slow down, it will be delayed, it will take more time to come out of the that medium. So if you look at this figure, here we have considered a concave mirror. Okay, it is a kind of mirror. So we are incidenting plane wavefront on this mirror. So the upper and lower part of this wavefront initially touches this mirror, so they readily reflected back from the this surface, but middle portion of this wavefront has to travel more distance, so that the reflected wavefront will is converging to one point. So this is what we can observe here. So the reflected wavefront will be a converging wavefront. Let us look at the third one. What happens if the wavefront is passed through a double convex lens? So when it passes through, when the plane wavefront is passed through a double convex lens, the middle portion of the wavefront has to travel more distance than the wavefront which are entering at its edges. So that is why the refracted ray the ray which is coming out of this double convex lens will also be a converging wavefront. See, this is converging, so it converges to some point, so that image will be formed over here. So this is what we learnt in ray optics. So using the wave concept, we can explain all these phenomena. We can explain in using the different mediums.